Hello everyone, this is Siddiqur Rahman and welcome to the first continuation of the first lecture of the third week. So let's start. By the end of this lecture, you guys will be able to describe about OR gate, Xor gate and Nand gate along with its symbol, truth table, application and so on. So let's start with the outline. From this slide, you may learn or you may notice that from this slide you may get an overview of this lecture, and from this lecture you may know some of the familiar logic gate such as OR gate, XOR gate and NAND gate, and along with this you may know also its symbol and truth table and application. So let's start with the overview of OR gate. The OR gate is a digital logic gate with n inputs and one output that performs a logical conjunction based on the combination of its inputs. The output of the OR gate is true, which means 1, or you can say high, only when one or more inputs are true. If all the inputs of the gate are false, which means 0, or you can say low, then only the output of the OR gate is false. And figure 1 represents the figure 1 represents the symbols of OR gate, and you see two figures, or you can say two symbols is represented in figure 1. One is traditional symbol and another one is IC symbol. From this slide you may learn the truth table of OR gate, and one thing is important to mention for this slide, and the OR gate we discuss in here has only 2 inputs, and from the table you may notice that there are 2 inputs already mentioned. One is symbolized or designated by A and another one is designated by capital letter B or English alphabet B. Well, and the output section or you can say the column of output you get from the OR gate, output A or B, and the function of OR gate is close to the function of, or you can say the operation of addition of mathematics. So let's start. Since this gate has 2 inputs, so we may assume or we may assign 2 binary values. One is 0 and another one is 1, and the combination of these 2 values gets 4 combination such as 0 0 0 1 1 0 and 1 1, and we get in the output section when the inputs are 0 0, in that case you guys get 0. When the input section 1 is inputs, I repeat again, when the inputs, one of input is 0 and another one is 1, in that case you get 1, and the vice versa, one is 1 and another one is 0, you will get also 1. And when the 2 inputs are also 1, which means A is equals to 1 and B is equals to 1, in that case you guys also get the output 1. Now from this slide you may learn application of OR gate. So let's start. Alarm circuit for car door system. We design this alarm by connecting 4 circuits to the 4 doors of the car or any vehicle. Well, when the door is open, the circuit generates high output, which means logic 1. And similarly, when the door is closed, the circuit generates 0, which is equivalent to logic 0. The 4 output of doors are connected to a 4 input OR gate, which output is connected to an alarm. When any of the when any one or more doors are opened, then the output of 4 input OR gate is just 1. Then the alarm rings so that we can know the condition of doors, whether they are properly closed or not. And you may notice that the figure represents the alarm circuit for the car door system. And we already mentioned that in a private car there are 4 doors, and this represents the 4 inputs of this OR gate. So let's start with the next slide. Well, from this slide we may learn an overview of XOR gate. So let's start. The XOR gate, which is also known as exclusive OR gate, is a digital logic gate with 2 inputs and 1 output. The short form of this gate is XOR, EX-OR. It performs based on the operation of OR gate. If any one of these inputs of this gate is high, then the output of the XOR gate will be high. And figure 3 represents the symbol of XOR gate. And you may notice that there are also 2 symbols. One is traditional one and another one is IEC one. So let's move into the next slide. From this slide you may learn the truth table of XOR gate, and also you may see from this table this gate also 2 inputs. One is symbolized A and another one is symbolized B, and the output in the output column we get A XOR B, and in the output section you guys notice that this symbol is not familiar. That's why for your understanding the simplification of this line is sorry, I repeat again, for your understand, the simplification of this line is mentioned, or simplified version is presented after this line. So we start, if we see the simplified version of the output section of XOR gate, then we can find output is symbolized by a alphabet which is Q, and which is equal to A B bar, A and B bar. You can say in this way, A and B bar, or not B, you can say that, or A, sorry, I repeat again, not A and B, or you can read as simple as like A B bar plus A bar B. Well, since this gate has 2 inputs and we assign 2 binary numbers, one is 0 and another one is 1, which is if we combine these 2 numbers, then we get 4 combination. One is 0 0, second one is 0 1, third one is 1 0, fourth one is 1 1. Well, and the output section, if we see, then we get when the inputs are 0 and 0, then we will get 0. If the input is if one of the input is 0 and the other input is 1, then we will get 1. And vice versa, if the one of the input is 1 and the other one is 0, then we also get 1. If one of the input is 1 and another input is 1, then we'll get 0. From this slide we may learn some of the application of XOR gate. These type of logic gates are used in generation of parity generator and checking units. The 2 diagrams below shows the even and odd parity generator circuits respectively for a 4 data and first one is represented even parity and second one is represented odd parity. And maybe a question may arise in your mind, what is parity? For your information, you guys will learn about this parameter in the sorry, I repeat again, for your information, you guys will learn about this parameter in future lecture. So let's move into the next slide. From this slide we may learn about the overview of Nand Gate. So let's start. The Nand Gate is a digital logic gate with n inputs and one output that performs the operation of the AND gate followed by the operation of the NOT gate. Nand Gate is designed by combining the AND gate and NOT gate. Well, if the input of the NAND gate is high, then the output of the gate will low. Well, figure 5 represents the representation of symbols of the NAND gate, and here also you guys find two symbols are represented. One is traditional symbol and another one is IC symbol. From this slide, you may learn about the truth table of NAND gate. Well, you see from the table, NAND gate has two inputs in here, and one is symbolized capital A and another one is capital B, and the output is similar to AND gate, but here another thing which is and A and B, you can read in this way, A and B, but or you can say not A and B. Well, since this gate has two inputs and we assigned two binary numbers, one is 0 and another one is 1, and if we combine these two numbers we get four combination of these numbers such as 0 0 0 1 1 0 and 1 1. And if we consider when the two inputs are 0 0, in that case we get 1, and if we consider one of the input is 1 and another one and another one is 0, in that case we'll get 1. If we consider the two inputs are equals to 1, then in that case we get 0. So let's move into the next slide. From this slide we may learn the applications of the NAND gate. So let's start. Burglar alarm. When the switch is closed, one input of the NAND gate is low. When the LDR is in the light, the other input is low. This means that if either of these things happen, that is the switch is closed or the light is on, one of the inputs is low, the output is high and the buzzer sounds. Another application of the NAND gate is freezer warning buzzer. So let's start. When the thermistor is cold, its resistance is large and the input of the NAND gate is high. Since the NAND gate is connected as an inverter, as we already know from the overview, the output is low. As the thermistor warms up, its resistance decreases. The voltage across its, I repeat again, across it falls and the input to the NAND gate falls. When it becomes low enough, the output becomes high and the buzzer sounds. In the next lecture, you guys will know about NOR gate, XNOR gate and NOT gate. That's all for this lecture, and thank you guys for your attention. See you guys in the next lecture. Thank you.